So I want to talk a little bit more about classes, giving a little bit more, showing a little bit more of what they can do, and hopefully showing a little bit more of why they are useful. Okay? Now, one of the problems is that to construct something like this, we're going to use a toy problem, which means that I may overlook some of the complexity that comes with a real example, but hopefully it keeps it clear enough to use. All right? So we're going to create a class. So we just say class person, and typically we capitalize class names. I don't know if that's the case in Python or not, but I typically do. It's not a rule, it's just a typically. And inside of the class person, we can define behaviors and data. Now, Python is a little different from some other languages in that the only way you can define data is through an initialize function. So it's called def double underscore init double underscore. That's a magic name, okay? It always takes self, which is the object being created, and then you identify the data associated with the object. So we're going to say self.mName equals none. So a person is going to have a name, but by default we won't say what the name is. Self.mAge equals none. Actually, no. Let's take that back. We're going to make the default age, we need to import time, so we've got something to use here. And I didn't mean for that to be ager, I meant age. We're going to make that time dot time. Alright? So what does this mean? Well, m is just another naming convention. M underscore. When you see a variable named m underscore, in my usage that means that is data associated with an object, in this case a person object. And so when a person is created, it won't have a name, but it will have an age. So that's as if the person were born when this happens, right? So down here I'm going to say person1 equals person. And now I'm going to try saying print person1. Let's see what that does so far. All right. So it says it's a person object at this weird number. Wow, that's pretty interesting. So main comes from the fact that all of this is main, right, when I execute this file. Person is the class name, and it emphasizes that's an object because it's telling us the type. At means this is the location in computer memory. Not a very useful factor. Now obviously I could say person2 equals person and print person2, and we'll see that they have different addresses in memory. That's nice. It's kind of hard to keep track of them that way though, right? Well, let's look at maybe we should require a person to have a name. Does that sound like a good idea? So we're going to add this to the init list. We're going to say, in fact, not just a name, we're going to say first name, last name, okay? And so now we're going to say, up here, instead of m name, we're going to say m first name equals first name. Now notice I call the parameter passed in first name, and I call the data associated with the object m first name. There's nothing magic about first name here and first name here, except that I assign first name to m first name. This is just a naming convention. We'll see some of why that matters in a moment. So I'm going to follow that convention though. M, whoops, no underscore before. M last name equals last name. Okay. Now let's suppose, so now I have to say John Jones, and this person is Mary Brown. Okay, let's see what's happened now. Well, not too surprisingly, nothing. Because I didn't give it any behaviors related to the names. So for just a moment, we're going to do something a little different here. Now we're going to say def name, self. So self is the object that's being passed in. And I think that self is a magic word. I'm not sure. It's entirely possible we could use a different variable name. But since it changes colors, and I know that's the convention, we'll use self. This is the object. So when you want to ask for a person's name, you call the name function or the name method. And we're going to return self.m first name plus a space plus self.m last name. And that's going to be the person's name. So now I can say print person1.name and print person2.name. And now we get something more interesting. We've got John Jones and Mary Brown. And so the behavior here is when you request its name, the person class determines how a person reports their name, which in this case is the first name followed by the last name with a space dividing them. How about if we wanted to know how old a person was? So we need to define another behavior. We're going to call it def age, self, because we always need the self. That's the object we're going to ask about the age of. So what is a person's age? Well, it's return time minus self.m, whoops, not age. This is not age. This is birth time, right? I called it age, and that was very misleading. So age is time minus birth time. And so now if I say print person2.age, let's see what happens. Okay, so Mary Brown is 7 microseconds old because it doesn't take very long to get from birth to here. How should we deal with that? Well, how about if we ask for a birth date instead? Is that all right? So instead of saying they're born at the moment they're created, let's ask for a birth date. Okay, and so John Jones, I asked for the birth date first. That's a little confusing. Oh well. Let's say October 25th, 2002. And Mary was born on what? January 7th, 1998. So now my birth time, well, birth date is a string here we can read, so we need to convert that into a birth time. Time is in seconds here, since sometime. It happens to be since January 1st, 1970, I think. So now we're going to do, we need to turn that string into a time, and this is a little complicated, unfortunately. So we do stirp time, birth date. That means string parse time, birth date, and we have to tell it the format of the birth date, which is month Why does B mean month? I have no idea. D for day, that's pretty intuitive. And Y for year. But that unfortunately gives us a structure, not a number of seconds. So we have to go, and I also forgot the fact that we need to do time dot and time dot. Now we should see a more interesting age for Mary. Ah, okay. Well, that's a more interesting age, but it's an age in seconds. Usually we want to know a person's age in years. So all we're going to do is we're going to change the behavior here. We're going to say that's the number of seconds divided by 86,400, which of course is the number of seconds in a day, right? You don't believe me? Should have memorized that. Times 365. We're going to ignore leap years for the moment, okay? And so now we can see that Mary is 22.8 years old. We don't even care about that, do we? So we'll say int. So now, whoops. I needed to wrap int all the way around that. So now Mary is 22 years old. And we can also see that person 1 dot age is 18. John Jones is 18 years old. So we've defined an object, a person. This person has a first name and a last name and a birth time. And we can now ask that person for their name, which gives us their first name and last name. And we can ask them for their age, which gives us their age in years. That's all very good. What can we do with a person? Well, we've done just about everything we can do with these people. But there's something else we can do which is kind of interesting. We could define a class let's define a class employee. Okay? And what I'm saying there with those parentheses is an employee is a person, but there's some more information we need to know about them. And so we want an employee to have a company and a hire date. Okay? Maybe there's more things we can know about an employee, but let's say that we have those. So now, remember, to define data, we have to have def init with 2 underscores on either side, self, and we need to have a birth date, a first name. Why do I need these? Well, remember, an employee is a person. In order to create a person, I'm going to need these things. And we'll see how I use them in just a minute, all right? Now we're going to need company and hire. I'm going to call it hire time since we're doing in seconds here. No, maybe we'll call this a date. We'll be allowed to pass in a string. So first we have to do super.init. That looks kind of strange. What does that mean? That means we're going to call the init method for person first, so we fill out the person. And obviously we're going to pass them the birth date, the first name, and the last name. Then the employee has self dot, oops, do I need to pass self there? I probably do. Guess we'll find out in a minute, won't we? Okay, I'm going to have m hire time, pretty much the same thing, right? Equals, and we're going to just copy this code down here, which suggests I should have a function there, right? We'll get to there maybe. hire date. And so hire date has to be in the same format. And then self.company, self.mCompany, because I like that convention, equals company. So let's see what happens if I say employee 1 equals employee. And this employee was born May 5th, 1964. And let's see, first name is George. Last name is White. Company is BYUI. And the hire date is September 22nd, 2011. Okay? Let's just try down to there and see if I've messed anything up. Trace back. Okay, init requires a super object, but received an employee. Interesting. All right, let's read the documentation. Python class inheritance. Let's see. Okay. Base class name. Virtual. We won't get into that today, definitely. Mapping subclass. Whoops, that doesn't. All right, let's try Python super.init. That's not very useful. Real Python. Okay, class rectangle, init self length width, square init self length. Oh, square doesn't inherit from rectangle yet. Okay, square rectangle, def init, super.init length. So super is a method, not a variable. Super.init, like that. Let's see what that does. Okay. So I've now created an employee. How old is this employee? Well, I can just say print employee1 dot age. Did I define an age for an employee? No. But as it turns out, because employee is a person, anything you can do to a person, you can also do to an employee. So I can ask the employee for his age. I can ask the employee for his name. And so I didn't have to define those methods for an employee because they were already part of a person. But I can define additional behaviors for an employee. For example, let's say def time with company self. So now I'm going to return self dot m hire time minus, whoops, I did that backwards, didn't I? I need to do return time. Ooh, did you know you can spell time that way? Time.time minus self.hire time. And that's going to, so now I can say print employee1 dot time with company. And of course that's going to give us a number of seconds, so maybe that's not too useful. So maybe we'll return that as years divided by 86,400 times 365, again ignoring leap years. So now we see that George has been with BYUI for 9.1 years. And of course now since I've got all those decimal places, I can see now he's been there for just a little bit longer. We have to go clear out to here before we can see any difference, but there is a difference there. Now, can I ask print person 1 or person 2? Can I ask person 2 about his time with company? What do you expect to happen? Now, in fact, it's going to say person object has no attribute time with company. So an employee has a time with company, and an employee is a person. But a person is not necessarily an employee. All right? So we can ask about time with company for an employee, but not for just any random person. So I hope that this has given you a little bit more insight into classes and what they're good for. You can carry around all the information about a person with just that one variable. Any person knows his first name, last name, and birth time, and you can ask them about their name and their age. You can also define other objects which are a person but have additional behaviors, like an employee who has a time with company. Now, one thing that I didn't show here, what company is employee 1 with? Well, you can say print employee1.m company and find out what company employee 1 is with. But typically we don't want to do that. Now in Python there's nothing keeping you from doing that, by the way. But usually you want to define a behavior instead of requesting the data directly from an object. And so def company, for example, or maybe, who knows, maybe we call it company name. Return m company. And so then instead of asking for the m company directly, we ask for the company name of the employee. The result is the same. Whoops. M company is not defined. Really? Self.m company. Always. In other languages, self is not required. Neither here nor here. But in Python it is. In C++ it's not. And so I'm not in the habit of using it, and that's why you see me make that mistake, and you'll probably see it again. So this looks the same, but the idea is that the object owns its own data. You don't do anything to the data of an object directly, usually. Some people don't feel that way. I try not to manipulate the data of the object directly. I always call member functions or methods to handle the data, whether it's just to return the value or to do something with it. Let's suppose we want to know a person's weight. Def weight. Now, have we said anything about the person's weight up until now? We haven't, have we? And so in this case we might say if self.m weight equals none, I think we can do that. Self.m weight equals 0, return self.m weight. Well, that's kind of interesting. So let's print person2 dot weight. Person object has no attribute m weight. So how can we figure out whether it has an m weight? Is there an is none? Python is none. Not none test in Python. Okay, what error did it give me? It said attribute error. Okay, so now we're going to use error handling, all right? Instead of this, we're going to say weight, let's see, returned weight equals self.m weight. And we're going to do returned weight. Except now we're going to put a try around this. Except, and it really doesn't matter what the exception is. I'm going to say self.m weight equals 0. That's kind of irritating. Can I just do this? What's the, is it finally? Returned weight equals self.m weight. Let's see if that works. There we go. And so Mary Brown's weight is 0 because we haven't given her a weight. And that's kind of the default value if there isn't a weight given. But now I can define a def set weight self weight, and I can say self.m weight equals weight. And so now I can say down here person2 dot set weight 105, and now I can say print person2 dot weight, and I should get 105. Sure enough, weight goes from 0 to 105. So what happened? By not manipulating the weight directly, I could ask for her weight, and the person itself, herself, defined how to respond in the case where there was no weight set. And so if there is no weight set, the weight is set to 0, and that is what's returned. Or I can set the weight directly this way. But I still don't manipulate the data. I don't say person2.m weight equals 105 right here, sorry. I call the method to do it. Because perhaps Mary wants to record her weight in ounces. Or there could be any number of things that want to go on inside. I shouldn't look at the data directly. I should always call the methods which define the interface to the object. Okay? And of course now I can also say person1.weight or set weight 150, and I can say print person1.weight, and then I should see a 150 somewhere in that list. There we are. And of course I should be printing more information because this is just a string of stuff and it's hard to tell what goes with what. But this is an example of how a person can define what happens when their weight is requested and no weight has been set. All right. Of course, there's entirely another way of handling this. We could also just say a person always has self.m weight equals 0. So there's always a weight defined, in which case we don't need to do the error handling here, and we could just do return m weight. And a weight only becomes meaningful if set weight is called first. So you can see I can change the internal representation here, but the external still looks the same. Whoops, m weight is not defined. Oh, self dot. See, like I say, I keep forgetting that. Okay, so the external behavior is still the same. When I asked Mary Brown's weight without doing anything, the weight was 0. When I set her weight and then asked for it, it's 105. But I changed by giving a default weight here instead of a default weight down here. Obviously, in this particular case, this is cleaner. We expect a person to have a weight. But I changed the internal behavior, and the external didn't see any change because it's all defined by the person object. All right, that meandered on quite a while. I hope that was useful to you. And actually, I would appreciate it if you would post questions to this, to the announcement if you have questions about classes, and I can answer them there for everybody. All right? So thank you very much. Like I say, hope it's worthwhile. Thanks for watching.